Okay, so from part one, the goal was, I don't know if you caught it, but the goal is to turn the system of three equations into a 2 by 2 system and then use elimination, substitution, whatever method you prefer, okay? So for this one here, for example number 2, what I am going to do is I'm going to take the third equation, okay, and I'm going to copy it here. So 5x plus z equals, let's see what this one says, 7, right? So I am going to isolate the z because it has a coefficient of 1. So minus 5x on this side and minus 5x on this side. So then we have the z equals negative 5x plus 7. Okay, then I'm going to go to the first equation and substitute for z. So I have x plus y minus, this is negative 5x plus 7 equals 0, and the other is 3x minus y plus, then this is, we just said that z is negative 5x plus 7, so negative 5x plus 7, and this is equal to 4. So there we have the two equations. So then notice that this negative is going to change the sign of the t of these two terms inside of the parentheses, okay? So x plus y, this becomes plus 5x, and this negative 1 times 7, that's minus 7, that equals 0. So then simplify by combining x and 5x, so then we have 6x plus y minus 7 equals 0. Then let's add the 7 to both sides of the equation. So then we have 6x plus y equals 7. Okay, so that's the first equation. Now the next one, notice we only have two variables, which is the goal, okay, to get only two variables. So then we have 3x minus y, this is negative 5x plus 7 equals 4. 3x minus 5x combined to negative 2x, and then minus y plus 7 equals 4. Then let's subtract the 7. So we have negative 2x minus y equals negative 3. Then what I'm going to do next is I'm going to put these two equations together. So I have 6x plus y equals 7, and the other is negative 2x minus y equals negative 3. But notice that the y's are going to get eliminated because one is positive, the other one is negative. So then we have 6x minus 2x, that's 4x, equals 4 minus 3, that's 4. Then divide by 4, which means that x equals 1. So we have the x coordinate. So then what I'm going to do is I'm going to go to the first equation here. So I'm going to take this one and copy the 6, but we know x is 1. So instead of 6x, 6 times 1 plus y equals 7. And 6 times 1 is 6. And then we subtract the 6 from both sides. So then y equals 1. Okay. So then since we know x and y, let's find the z coordinate. So let's go back to this equation that we came up with. Okay, so then z is equal to negative 5 instead of x. X is 1, right? So negative 5 times 1 plus 7, which means that z equals negative 5 plus 7. So z is equal to positive 2. So then these three lines are going to intersect at these coordinates where x is 1, y is 1, and z is 2. So this is the solution to this system of equations. So let's move on to the last example. So notice that in the second equation, we have the x isolated, okay? So what I'm going to do is I'm going to copy or substitute for x in the first equation. So instead of x, I'm going to copy 2y plus 1 instead of that x plus 3y plus z equals 0. Then I'm going to simplify by combining like terms. 2y and 3y combine to 5y. And then plus z equals, sorry, not yet. Okay, let me not jump the gun. Okay, so plus 1 equals 0. I'm going to subtract 1. So then 5y plus z equals negative 1. So that's one equation. Then I'm going to go to the second equation and then substitute for x here. So then this one is 2 times, instead of x, 2y plus 1 minus 2z equals 18. Okay, then I'm going to distribute this 2. So 2 times 2y is 4y. 2 times 1 is 2 minus 2z equals 18. Then I'm going to subtract the 2 from both sides of the equation. So we have 4y minus 2z equals 16. So then I'm going to combine these two equations next. I'm going to use elimination. Okay, so I have 5y plus z equals negative 1. And the other is 4y minus 2z equals 16. I am going to eliminate the y's, which means I'm going to multiply the first equation by 2. So I'm going to write a 2 here. And then I'm distributing. So 2 times 5y, that's 10y. 2 times z, that's plus 2. Z, 2 times negative 1, that's negative 2. And then I'm just going to copy the second equation for y minus 2z equals 16. So then, as you can see, the z's get eliminated. Then 10y plus 4y, that's 14y, equals negative 2 plus 16, that's positive 14. Then divide by 14, which is what we have in front of the y. So then we find that the y coordinate is equal to 1. So then we can go to this equation to find the z coordinate. Okay, so then this is 5 instead of y. We just found that y is equal to 1. So 1 plus z equals negative 1. So 5 times 1 is 5. So 5 plus z equals negative 1. Then subtract the 5 from both sides of the equation. So then we find that z is equal to negative 6. So we have y and z. Now let's find the x coordinate. Okay, we can go to the second equation. So let's see, x equals 2 instead of y again. We just found the y is 1. So 2 times 1 plus 1. So 2 times 1 is 2. And 2 plus 1 is 3. So x equals 3, which means the point of intersection of these three equations is or happens at the following coordinates, where x is 3, y is 1, and z is negative 6. And this is the solution to the system. All right, thank you for watching. I'll see you in the classroom. Bye-bye.